Self-promotion, trying to bring that walk out right into the weapon. Gonna be good for slamming and controlling.
Sonic was certainly ready. Spin a Rudy and take it inside.
Hey there, this is Seth Schaefer from Team Robotics, and in today's video, this will be a guide on the brand new WEKA Dual ESC that is just coming out from Just 'Cause Robotics. This ESC has been powering most of my robots at competitions for the last year, basically. This has been in development since September of last year. It has competed inside of SSP at Bot Brawl and other tournaments, inside of Subtraction at every competition Subtraction has been to, and even in Division version 4 at its first tournament. So this guy has definitely been battle tested. I've had no failures in my own robots. I've sent it out to a bunch of beta testers with mostly good results, but there were a few issues that had to be worked out, which is why it's taken so long to get this out the door. I didn't want to release a subpar product, but I just wanted to show how tiny, lightweight, and efficient this guy is. So, starting off, it weighs 3 grams. If you add on the weight of connectors, it is about 13 grams. To put that into context, this is the budget ESC. So it's more than twice the weight with connectors, but the size difference is just immense. I mean, this is like 1/6 of the volume of one of these guys. It's about the size of a Malenki Nano, but it doesn't have a receiver built in. And it also compares to the Terracan, even the newest, smaller version of the Terracan ESC, it's like less than half of the size. About the same width, but less than half of the length. And the Terracan by itself is more than double the weight. So this is a huge improvement over existing brushed ESC technology, and it's a dual 20 amp ESC, so it's actually rated for even higher current than this guy or this guy. As far as size goes, it is about 20 millimeters by about 30 millimeters, and the thickness is going to be much bigger with the wires, but without wires, only 3.43 millimeters thick. So absolutely tiny. When you order this, it will come in a in a anti-static bag. It will come with a small length of heat shrink. This guy does have built-in mixing, and you can disable that easily. I'll go over exactly how that works in a bit, but basically there's a magic Simon Says calibration, whereby you plug this into your receiver, you plug in your motors, and then you twitch, or it twitches the motors. Like, let's say it twitches this way, you'll just do whatever input on your transmitter you want to turn left, whether it's a single stick for arcade, or one forward and one backward for tank drive. And then it'll twitch a different way. Let's say it twitches forward, then you'd say, okay, one stick forward for arcade, or both sticks forward for tank drive. And then it'll do another blinking thing and twitch again. Then you'll just do any input to confirm whether you want to turn on braking, or you just wait to have braking turned off for like 10 seconds. And from that point forward, it's calibrated and set up for your radio. And I'll show that process on camera at the end of this video. But it makes it super, super convenient, because imagine if you're in the pits, you're making frantic repairs to your robot, you accidentally switch which motor is on which side. You don't even have to change the soldering or unplug motors and plug them back in. You can just enter that calibration again by jiggling the stick a bunch of times as soon as this is powered on, and then you can recalibrate it on the fly and have it work the way that you need it to without needing to change up your wiring whatsoever. This is the only speed controller that I know of on the market that allows you to do this. And it will also come with everything you see here. So 2 servo PWM connectors for the signal wires, 2 JST leads with 20 gauge silicone wires for the motor connections, and 1 already soldered on XT30U connector for power. So I'm going to show how to solder this up, but it's really straightforward. So as far as how to wire up the connections, I'll go over that by showing you how to solder everything in a minute. But your JST leads for motors, those black and red doesn't matter to M1A, M1B, and then your second motor, M2A, M2B. For your battery and your signal wires, the colors do matter. So red is positive, black is negative, just like in everything else ever. And those will go like that with your XT30 connector on the other end. Then you got your signal connections. So if my camera will focus properly, so you've got ground, 5 volts, and S1. So that's S1 as in the signal for motor number 1. So those will be like that, black to ground, red to 5 volt, and white to S1. And then your second one, you can actually cut off the red and black wires, you don't need them, but you just need that white wire for S2. And that'll be for controlling that second motor, motor number 2. If you're looking to make your own awesome assembled PCB products like the WEKA ESC, you should check out today's sponsor, PCBWay. They currently have a 10th anniversary sale going on, so you can get special deals and better prices than you could year-round on a ton of their awesome CNC fabrication and PCB production features. They can make pretty much anything as long as it's designed properly for the manufacturing method that you've chosen. So check them out at the link below and get a $5 user credit towards your first order. As you can see here, I've been using PCBWay for quite a long time, and they have always been awesome to work with. Alright, let's start off with our power connections. So I've got my iron here, I'm setting it to 300°C, it doesn't need to be a specific temperature, but just needs to be hot enough to melt solder, basically. Normally I would turn on a fume extractor, but because this is a video and I want you to be able to hear me talk, I'm not going to bother with that. So heat up some solder here to the pads. Now all the wires come pre-tinned, so if you want to leave them the length that they come, then you don't have to do anything, but if you cut them shorter and you strip them, make sure that you twist the leads together, or else they might fray out and bridge the connections, because they are kind of close together, because this board is so tiny. So let's start with power. So we're going to melt this solder to get it nice and hot, and then we put the iron on top of the power lead, feed in some more solder, and just kind of get those 2 pools of solder to join together properly. And just make sure that we've got a nice uniform connection there. I'm applying on it once it's held in place, and there we go, that's one of the connections done. Repeat the process here, get both the wire and the pool of solder hot. Iron on top, feed in some more solder. This device I'm using to hold this is called the OmniFixo, by the way, not sponsored or anything, but it's quite handy for holding small electronic components like this. But a set of regular helping hands can do this just fine, or you can honestly just lay it flat on a table, and that works pretty well too. Now for the servo leads, start with number 1. So we want to do ground, melt the pad, wire over the pad, get the 2 things to kind of join together. It can be a little tricky to hold these smaller wires in place, but you get the hang of it eventually when you've done as many as I have. Same kind of deal with this one. And last but not least, this one. There we go. Probably could have trimmed off a bit of excess there. This one's not as flat to the board as I would like it, so I'm just going to remelt it real quick. Cool. And then we'll do that white wire for S2 on the other connector. Whoops. There we go. Cool. I'm just going to grab some flush cutters here and trim off this little bit of excess that we don't need. And now we'll get those out of the way. I'm going to trim off these because I don't need them. You could hypothetically pull the pins out, but I like having the extra pins there so that they hold into your receiver a bit better. I'll just throw this back in the Fixo jaws. So if you aren't as unconcerned with burning yourself as I am, because maybe you have a bit less practice, this is where the OmniFixo really comes in handy. So I'm just going to do A for now. We don't need to get my fingers in harm's way at all. I can move this guy to this side and do the other one. And this one I'm going to intentionally do reversed so that I can show the calibration thing working correctly. So I think the default will have it kind of close to what I want otherwise. Alrighty, so I'm going to inspect my connections, make sure that I can tug on the wires and nothing comes loose. Cool. Next, let's get our heat shrink on here. So we've got some mega oversized heat shrink. I know it seems like this shouldn't work, but most heat shrink tube is a 2-to-1 shrink ratio. This is actually a 3-to-1 shrink ratio, so it gets way smaller. So I'll get that over there. Grab our heat gun. Alrighty. That is ready to use in a robot now. Alrighty. So now let's demonstrate how this is supposed to work and how to do the calibration. So I've got an SSP kit here that this is the one that I actually computed with at Bopral and already has a WEKA in here that had a dead BEC, but because the motherboard has its own BEC, that didn't matter. This also has a prototype motherboard in it, but it'll function the same as if it was a standard SSP kit. So we got this guy. Normally, if you're powering this with a battery, you could plug a battery directly in, it'll turn on. That red LED indicates power, and this alternating blue flashing LEDs indicates that this is not getting a signal from a receiver. If I have a receiver here, and we plug it in, we want channels 1 and 2 plugged with the white on top and black on the bottom. Doesn't matter which goes to which because of the calibration. And assuming I actually did this correct, we should be getting receiver power now. There we go. Now it's still flashing because it's not getting a signal from the receiver, or the receiver isn't armed rather, because it's not connected to a transmitter. So we turn on the transmitter, boom, that red LED turns solid, and the WEKA's blinking goes away. We push up and down on the sticks, and the lights indicate what the WEKA is trying to do. So now we can connect this to the motors, and this will probably try and drive off the tabletop. Forward, backward, left, and right. Obviously those are messed up. It's doing turning when it should be straight, and it's doing straight when it should be turning, but that's how we can fix that with the calibration. First, just for convenience sake, I'm going to plug this back into the motherboard, because we have to be able to turn the WEKA on and off for calibration quickly, and there's a power switch built into the SSP kit's motherboard to make that easier. And then these connections will go to this FS2A receiver in here. Alright, so let's turn the SSP kit on. I'm holding the black button on this so that I can bind it to this radio. So, this is a brand new model with no mixing or anything set up properly. Whoops, and of course the servo angles are set wrong. Alright, so this one is now behaving correctly, but I can switch the motors and then it won't be, so I can show the calibration. So let's say you were fixing your robot in the pits. You accidentally crossed your wires. You plug the left motor into the right motor port and the right motor into the left motor port. Oh no, when I push forward now, it's correct. So when I try to steer, it's going in the wrong direction. Whatever shall I do? So what we're going to do is we're going to power this off and then on. And then as soon as we power it on again, we're going to jiggle this stick like this to enter the calibration mode. You have to cross the 0 position like 10 or 20 times or something. Okay, so now both blue LEDs are flashing, indicating we are in calibration mode. So what I'm going to do is I'm going to put the robot on the floor, and then I'm going to put any input. Alright, so the robot spun to the left. I want this to be my input to turn left. And now it drove forward, and I want this to be my input to go forward. And then I'm just going to do any input to say I want to enable braking. And boom. Now it's set up the correct way, turning the correct way, and everything else I wanted. And if we turn the robot off and on again, I'll show with the lights off and then on. It remembers the calibration, so everything still turns the correct way and whatnot. Behaves how I want. Now let's say all of a sudden I decide I want to switch this to tank drive, which is not going to work well with the servo plugged in, so I'm going to unplug the servo for demonstration. So I can do both sticks forward would go forward, and then one stick back controls the left motor, one stick controls the right motor. Alright, so I wanted to demonstrate how you can reconfigure stuff on the WEKA and transmitter and stuff. So for one thing, this is a different radio, which I just bound to it. But when I push forward, the thing goes backwards. When I push backwards, it goes forwards, but steering is correct. But I want to show this guy operating as a tank drive transmitter and show how you basically disable mixing on there. So to do that, I will have to make some adjustments on here to make it so that this stick can spring return. Alright, so by loosening these two small screws of the 1.5mm hex wrench, I was able to get it so that this stick now spring returns. So I can now do proper tank drive with this if I want to. Alright, so first thing I'm going to do is go into my input settings, and my aileron, which is this channel, I'm going to replace with this channel. There we go. So now this is forward and backward, but this no longer does left and right. Now this does left and right. So that's all messed up and weird. So let's fix it. So we turn the WEKA ESC off and then on. Do some input again a bunch of times to make it so it enters calibration mode. Cool. So now I'll do an input. So I want this. Now I want that. And then some input to enable braking. And now it is now not mixed anymore. So I have the ability to control both drive sides, one with this stick, one with this stick. And both forward, both backward. And I can bring this back to a screen that shows. I'm really not used to driving tank drive, but yep. So that's how you would disable mixing and enable a tank drive mode. So that just about wraps things up for the introduction to the WEKA ESC. This has been a collaboration between Just 'Cause Robotics and CB Technology, which is an electrical engineering firm run out of New Zealand by Connor Benton. He's been involved in the combat robotics community for a long time, even been a remote judge for a number of NHRL tournaments. So he has been developing products specifically for combat robots for quite a while. I partnered up with him to be the main distributor for this product, but you should also be able to buy it on his website from New Zealand directly if you happen to live there, or in Australia or somewhere closer to that hemisphere. But on justcauserobotics.com you can buy it if you live in the United States or anywhere close to the US. Check out the store page, linked down below, and happy bot building, everybody. Thanks for watching. Bye-bye.